Okay, I know I said I was going to move to quantum entanglement, and I will, but like I said, I'm super like fascinated by the light slit experiment, have been for like 20 plus years. So I just looked up some other examples that would support the same conclusions. So I'm mostly just going to read it off a screen here. But again, you can choose to look deeply into it if you want. But these are all confirmation of the same thing. This observer effect, like that, everything isn't quite what it seems. So there's the delayed choice quantum eraser. This is an experiment that shows that you can literally rewrite the past. It's John Wheeler, 1999. The photon is fired at a slit, but after it passes two, it is split into two entangled twins. One twin heads directly to a screen. The other twin is sent on a massive detour into a maze of mirrors. The experiments are set it up so that the maze can either reveal which slit the photon went to or erase that information entirely. The signal photon, that's the first one that went straight, hits the screen before its twin even finishes traveling through the maze. If the experimenters choose to look at the data that reveals the path, the signal acts like a solid particle. If they erase the path data, the signal acts like a wave. So that's one. There's another... Wheeler's cosmic delayed choice. This is another example where they did this on a galactic scale, right? So they're doing the same thing. Light's going around a quasar that's like billions of light years away. Same thing. It behaves differently depending on the observer. And then this other one this one's fascinating. Wigner's friend. So, okay, imagine a scientist inside a closed lab who measures a photon. The photon collapses into a definite state for them, but to an outside observer standing outside the sealed lab, the entire lab, the scientist, and the photon are all still trapped in a giant wave of probability. When science ran this using an array of entangled photons simulating observers, they proved that both facts can be true simultaneously. The observer inside has one reality, and the observer outside has a different reality. And these are both true simultaneously. So basically, there is no objective reality. It's all created by us. Nothing is like certain, right? This one actually blows my mind. Another one, I don't know if I've mentioned it before, but like if you were to observe an atom that is supposed to decay, like whatever, let's say its half-life is 5 minutes, you can observe it for the 5 minutes and it won't decay. Like, and it won't at 10 or 15 or whatever, as long as you're looking at it, it's not going to decay. Again, this is the observer effect. But another example, like a riff on that same thing, is the Zeno effect, anti-Zeno effect. The constant observation freezes an atom. But physicists discovered the inverse. If you actually measure a quantum system at a slightly different frequency or rhythm, you can actually accelerate its decay for past its natural half-life. So you can basically, your observation actively controls the speed of physical time. So those are all the examples that I wanted to give that back up the last thing about, what even are we talking about here? The light slit experiment. Okay, next video for sure is quantum entanglement.